All right, let's look at this problem. The shafts of an angle drive are acted upon by the two couples shown, the 8-pound-foot one and the 6-pound-foot one, and the direction of the rotation is shown here. Replace the two couples with a single equivalent couple, specifying its magnitude and the direction of its axis. All right, so for the moment, remember, we're using right-hand rule, which means the rotation, you curl up your fingers in the direction of the rotation, and your thumb points towards the moment axis. This is moment, and this is a moment axis, or direction of the moment. So the rotation that shows on problems like this is just the direction of the rotation. So if I want to apply this right-hand rule to this two couples that I have, it looks like something like this. Curling my fingers like going, this one is a little bit more difficult. Well, is this correct? Yeah. The fingers are curling with the direction of rotation, and the thumb is pointing to negative z. And then the 8-pound-foot one, also the fingers are curling with the direction of the rotation, and then the moment axis would point up. So please try to kind of line up your fingers with the direction of rotation. You will see that your thumb will point down and toward negative z axis. So let's write these two as two vectors. So again, I put both of these here for reference, but let's see. If I have my two, let's see. So I have x, z, y. So one moment would be here, another one would be here, and you can place it anywhere you want along their line of action. I'm going to put it right here. So this one is the 6-pound-foot one, and I can have him any name I want. I place the other one right here. That's the 8-pound-foot one. Let's call this one moment of couple 1. Let's call this one moment of couple 2. All right, let's write them in Cartesian form. So moment of couple 1 in Cartesian format means ijk. It's pointing directly down negative y, so going towards negative y. So that's -8, and that's j. The units are pound feet. Moment of couple 2 is going towards negative z-axis, so that's -6. Z would be k. The units are pound feet. So I have them in Cartesian form, and it says replace the two couples with a single equivalent couple. What it means is find a resultant couple. So I got to add these two together. Cartesian form, there's just one j, one k, very easy. -8j -6k, and the units are pound feet. So this is your resultant moment. Single equivalent couple. Our job is kind of done already, but it asks us for specifying its magnitude and direction of its axis. So magnitude, to find magnitude of a force or a vector or a moment, you go -8 squared plus -6 squared, plus if you had an I, we would have squared that too, and the square root of that we have pound-feet, also the units of these, which are squared. If you do the math on this, it's a 8, 6, 10, so it will be 10 pound-feet. So that's the magnitude. And you see this right here, I didn't put an arrow because it's a magnitude. This one has an arrow, that means it's a vector format. So magnitude, we found it, 10 pound-foot. It's a vector, it's a 3D vector, only has J and K, but it's still a 3D vector. For 3D vectors, we usually identify them by the angles, but the alpha, beta, gamma, angle with x-axis, angle with y-axis, and angle with z-axis. You notice that I'm writing it a little bit differently, just to be more clear. This is my vector. Again, if you remember from coordinate direction angles, this component m cosine alpha I, m cosine beta j, m cosine gamma k. So this would be m cosine alpha, this would be m cosine beta, this would be m cosine gamma. M is the magnitude, and we already found it. It's 10 pound-foot. So therefore, my 0 equals 10 pound-foot cosine alpha. So 0 cosine alpha, so which results in alpha being 90 degrees, which makes sense. This vector is only on j, k, and y, z axis, so it doesn't have any component along x-axis. That means it has a direction of 90 degrees. So I'm going to go a little bit faster with these ones. Pound-foot. So your beta ends up being 143 degrees. And if you go 10 cosine gamma, then your gamma is going to be 127 degrees. So these three coordinate direction angles, I have a lecture on this, I have many problems on this if you would like to rewatch them, are the direction of the axis of your moment. Thank you very much.